Hello, good people. Welcome to my channel, King Academy. Today, I want to look at transformation, and we want to look at translation. Okay, so translation. These are congruent shapes. They are congruent shapes. So the question reads: triangle ABC was mapped onto triangle A2B2C2. Describe completely the single transformation. So if our triangle ABC was mapped onto triangle A2B2C2. So the question says describe completely the single transformation. So the first stage is to join our corresponding points A and A2. So we are joining A and A2, then B and also B what? B2. So we are joining our corresponding points, then C and C what? And C2. Okay? So we have joined our corresponding points. Okay? So if we join our corresponding points, as you can see, we are getting parallel lines, right? So they should be equal in length. So let's try to measure. It's 13.5. Then another 13.5, then B and B2 13.5. So we joined our corresponding points and we get parallel lines which are equal in length. That means that is translation. So we're going to answer. So translation. Then you want to get the what? The translation vector. TV is equals to ending point minus starting point. So triangle ABC was mapped onto triangle A2B2C2. So you want to find the translation vector. So ABC right here, that is our image. So our pre-image, that's the original shape, our pre-image. And this one right here, A2B2C2, is our image, which is our second shape. Okay, so that is our ending point right here. So we can take A point of A2, it's 4 and what? 4 and 2. That's our ending point. 4 and 2 minus starting point. So we're taking corresponding points A2 minus A, the starting point. So it's minus 3 and 3. Minus 3 and 3. So we're going to take minus 3 and 3. Okay, so 4 minus 3, you get what? 7. 4 negative, that's positive. So 2 minus 3, you get minus what? Minus 1. That's our translation vector. Okay, let's say you take B2 and what? And B. So I want to take B2 minus B. B2, that's 4 and what? And 0. 4, 0 minus B, that's minus 3 and what? And 1. Okay, that's minus 3 and 1. Okay, so 4 minus 3, what do we get? We get 7. 0 minus 1, we get minus 1. Okay, so what am I trying to explain here? If you take any point, either C2 minus C or A2 minus A or B2 minus B, we still get the same translation vector. So translation, it is the movement of shapes, lines and points without changing what? Without changing direction. Okay, let's say another question, say triangle A2B2C2 was mapped onto triangle A1 B1C1. They're saying triangle A2 B2 C2 was mapped onto triangle A1 B1 C1. In this case, triangle A2 B2 C2 is our pre-image. So A2 B2 C2 was translated onto triangle A1 B1 C1. So the first stage, we joined our corresponding points. We join our corresponding points A and what? And A1, B2 and what? And B1, then C2 and what? And C1. Okay, so as you can see, we are getting parallel lines, and they are equal in length from this point to this point, this point to this point, this point to this point. They are parallel and they are equal in length, and our shapes are congruent. So if you get corresponding points and you get parallel lines which are equal in length, it means it is translation. Then we are answering now the question, translation. Then what's next? Translation vector is equals to ending point minus starting point. So ABC was mapped onto A1, B1, C1. A2, B2, C2 was mapped onto triangle A1, B1, C1, which means this triangle right here, A1, B1, C1, is our ending point. So we are taking what? Our coordinates. In this case, let me take B1 minus B2. B1 is what? 1 and negative 3. So 1 and negative 3 minus B2. That's 4 and what? And 0. 4 and 0. So 1 minus 4. What do you get? You get negative 3. Negative 3. Negative 0. Minus 3 minus 0. You get minus what? Minus 3. That will be our translation vector. And if someone check C1 minus C2 or A1 minus A2, we will still get the same translation vector. So that's for translation. Thank you for watching, and please let's subscribe. Right, we have a question here. We're still on translation. Triangle ABC was mapped onto triangle A3, B3, C3 by a translation with translation vector 4, 2. Draw and label triangle A3, B3, C3. Okay, on this case we are given the translation vector, and remember our formula: translation vector is equals to ending point minus starting point. That's our translation vector. So we're going to write 4 and 2 is equals to ending point. That's triangle A3, B3, C3 minus starting point. That's our triangle ABC. So we are given triangle ABC with these coordinates. So the coordinates of A is 1 and what? 1 and 3. 1 and 3. So 1 and 3. Then B, that's 1 and what? 1 and 1. C, that's 2 and 1. Then 2 and 1. Okay, so it's like this. So let's take this bracket right here to this other side. So it's now 4, 2. Then it will be positive 1, 3, 1, 1, 2, 1. And our answer A3, B3, C3. Okay, so in other words, we are going to add our translation vector and the coordinates of A, B, and C. So that's our A, that's our B, that's our C. So 4 plus 1, you get what? You get 5. Then 2 plus 3, you get 5. 4 plus 1, that's 5. Okay, then 2 plus 1, that's 3. Then 4 plus 2, you get what? You get 6. 2 plus 1, you get what? You get 3. So these are the coordinates of triangle A3, B3, C3. So the question says draw and label. So A1 is 5 and 5. 5 and 5. That's A3. 5 and 5. That's A3. Okay. Then B3, that's 5 and 3. 5 and 3. So we're going to plot 5 and 3 right here. That's B what? B3. Then C3, that's 6 and 3. 6 and 3. So 6 and 3. And as you can see, we are still getting what? Congruent shapes. So that's translation. When you are given the translation what? Translation vector. So you just substitute from what? From our equation. So that's our triangle A3, B3. And if you join our corresponding points, you can see we get what? parallel lines which are equal in what? In length. Thank you. Alright, good people. So we are on reflection, and the important notes to take is on reflection. When you join the corresponding points, you get parallel lines which are not equal in length. So it's now different from translation. Translation, if you join corresponding points, you get parallel lines which are equal in length. But here on reflection, if you join corresponding points, you get parallel lines which are not equal in length. Then another important point is image and pre-image, they share the same distance from the invariant line. Alright, so we ask you to describe the simple transformation that makes triangle ABC onto triangle A1, B1, C1. Okay, so first thing is first, let's join our corresponding points. Let's join A and A1. A and 1. So I'm drawing some broken lines here. A and what? And A1. Then B and B1 and C and C1. They are in what? In a single straight line. So we are joining our corresponding points. Okay. So as you can see, we are getting parallel lines. Parallel lines. They are all parallel lines, right? Here C and C1, B and B1, A and A1. They are parallel, but they're not equal length. For example, A and A1, then C and C1. They are not equal length, yet they are parallel. So the only way is the only transformation that if you join corresponding points and you get parallel which are not equal in length is reflection. So we're going to write here reflection. So another thing is to find the mirror line or the invariant line. So on invariant line, remember I mentioned earlier on that if you get corresponding points, you get parallel lines which are not equal length. So image and pre-image, they share the same distance from the invariant line. Our pre-image here and image, they share the same distance from the mirror line. Okay, so we can count here from A to A1. How many boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8. And 8 divided by 2, so these two, they share the same what? The same distance from the invariant line. So 1, 2, 3, 4, that's the midpoint. Then C to C1, 1, 2, 3, 4. So the midpoint is 2, 1, 2. So it's right here. So meaning to say, this line right here is our mirror line or our invariant line. This one is our mirror line. So meaning to say, if you take B to this mirror line, and if you take B1 to this mirror line, we still get the same one, the same distance. For example, 1, 2, 3, 4, we're getting 4 lines. Then 1, 2, 3, 4, we're getting what? 4 lines. So which means to say this pre-image to this invariant line and this image to this invariant line, they are sharing the same one, the same distance. So it means it is what? Reflection. So it's what? In which line? This line is cutting through our x what? Our x-axis. So x is equals to 1. So in the line is reflection. In the line, what? Equation of a line is what? X is equals to what? X is equals to 1. That's the mirror line. Okay. So let's say you're asked to find, let's say they say triangle A1, B1, C1 was made onto triangle what? Onto triangle A2, B2, C2. In the line y is equals to 0. Let's say this is our middle line, the x-axis, right? So I want to reflect triangle A1, B1, C1 through this mirror. So let's count. Remember, image and pre-image, they share the same distance from the invariant line. So we're going to count from A1 to the invariant line. There are many boxes here. 1, 2, 3. Okay? So remember, image and pre-image, they share the same distance from the invariant line. So we're going to count another 3 boxes from our mirror line. 1, 2, 3. That's right here. So that's where there is what? A2. Let's take B B to the invariant line, how many boxes here? 1. So they share the same distance, so we're going to count 1 box to this point. So it's what? This one is B what? B2. Let's take C1 to the invariant line. How many boxes here? 1. So we're going to count another 1 box to this side, and we'll get what? A2. Okay. So let's draw our shape right here. So we are going to draw our shapes right here. Oh, this one is what? This one is C. Is C2. So let's join our triangle. Our triangle. Okay. Right here. Okay. So as you can see, we still got somewhat some congruent shapes. They are still equal. So when we join our corresponding points C and C1, B and B1, you get parallel lines which are not equal in length. So that's reflection. And on reflection, you should always treat that image and pre-image, they share the same distance from the invariant line. And another important note, if you join corresponding points, you will get parallel lines which are not equal in length. And image and pre-image, they meet at 90 degrees on the invariant line. So that's our what? Okay, so we're still on reflection. Okay, so we are saying triangle ABC was mapped onto triangle A2, B2, C2 by reflection in the line y is equals to x. That's our middle line. Draw a label triangle A2, B2, C2. Right, so that's our triangle ABC, which was mapped onto triangle A2, B2, C2 by the line y is equals to x. So what to draw the line y is equals to x. So how can we draw that line? So let's do this. Let's draw a table of values right here. So we draw a table of values, right? So this is x, this is y. So we are saying when x, we are just guessing any number. So let's say 0. So we are saying when x is equals to 0, y is equals to what? Y is equals to 0. Y, so we're going to substitute the value of x with 0, 0, so y is equals to 0. When x is equals to 2, y is equals to what? Y is equals to 2 again. So we're going to plot these coordinates 0 and 0, 0 and 0, right? That's here. Then 2 and what? 2 and 2, that's this side. So we're going to draw this line. So this line is passing through these coordinates right here. So I'm going to draw this what? This line. So this line is y is equals to x. Okay, remember, image and pre-image, they meet at 90 degrees on the invariant line. Okay, so let's take point A to this invariant line. Okay, we can take A to this invariant line. Okay, so let's take A. 1 new boxes, 1, 2, 3, 4, 5, 6. So they meet at what? 90 degrees. Okay, so I'm going to count 6 boxes again. 1, 2, 3, 4, 5, 6. So that's A2. That's A2. Or we would say 1, 2, 3, 4, 5, 6. Then we turn 90 degrees, reflecting 90 degrees. This side, then 1, 2, 3, 4, 5, 6. Okay, let's take B. B, from B to this invariant line, 1, 2, 3, 4. Then I'm going to turn 90 degrees, right? So they meet at what? 90 degrees. So that's our 90 degrees. Then we get 1, 2, 3, 4. Then 1, 2, 3, 4. So that's point what? That's point B, B2. Or we'd say 1, 2, 3, 4. Then 1, 2, 3, 4. Okay, let's take C. 1, 2, then 90 degrees. They meet at 90 degrees on the invariant line. Then 1, 2, So this point right here, that's C2, or we'd say 1, 2, the 90 degrees, 1, 2. So A, B, C was reflected onto A2, B2, C2. So that's our image right here, the image of triangle ABC. Okay, right? That's our shape. Okay, and if we join our corresponding points, we still get what parallel what lines which are not equal what in length. For example, B and B1, then C and C what and C2, A and A2, they are not equal in length. So that's reflection. So we've reflected triangle ABC through the mirror line y is equals to x, and the end result is this shape right here. Good people, we are on enlargement, right? So these are non-congruent shapes, and enlargement is making things bigger or smaller. So we have two shapes here, triangle ABC and triangle A2, B2, C2. So the question says, describe ABC was made into triangle A2, B2. Describe completely this single transformation. So first thing is first, let's join our corresponding points. Let's join our corresponding points A and what? And A2. So I'm joining my corresponding what? Corresponding points. Then B and what? And B2. B and B2. Then C and what? And C2. So I'm getting what? So when I join these corresponding points, they all meet at one common point. So this common point right here, where all these corresponding points are meet, it is the center of what? Enlargement. This point right here is the center of enlargement. So let's describe it. So enlargement, when joining corresponding points, they meet at one common point, and that common point is the center of enlargement. So I'm going to write enlargement, and if we join corresponding points, they meet at one common point. So center of what? Of enlargement. Center of enlargement, this is where these points are what? Are all meeting. So it's what? 3 and 0. So center of enlargement is 3, 0. That's the center of enlargement. So one last thing here is scale what? Scale factor. Scale factor. So scale factor is equals to image over pre-image. So the question clearly states that triangle ABC was mapped onto A2, B2, C2. So ABC is the pre-image, A2, B2, C2 is the image. Okay, so we can take this part here from this point B2 to C2. There are how many boxes here? 1, 2, 3, 4. And we are on the negative region. So it's -4. So I'm going to write image is -4 over pre-image. B and C, there are main boxes here, 1, 2. So it's over what? It's over 2, and 2 into 4 into -4, we get negative what? -2. That's our scale factor. So when you are describing enlargement, you have to mention enlargement, then center of enlargement, and scale factor. And when you join corresponding points, they will meet at one common point. At that common point, it is the center of enlargement. Okay, so let's say triangle ABC. Let me write here. Triangle ABC was mapped onto triangle A3, B3, C3 by enlargement. By what? Enlargement. Then they will say center 0, 1, scale factor minus what? Scale factor minus half. Okay, then they say draw and label, triangle A3, B3, C3. Okay, so this is our center. The center of enlargement is what? The center of enlargement, they said that it is 0 and what? And 1. That's our center of enlargement. So we can take each point to the what? To the center. So there are many boxes here from A to the center. There is 1, there is 2, there is 3. Times scale factor minus half. 3 times half, you get 1.5. So that's 1.5 right here. So this point right here is A what? A3. And enlargement is to make things bigger or smaller. So B to this point, to this end of enlargement, there are main boxes here. 1, 2 times scale factor minus half. That's what? That's 1 right here. So B is positioned right here. That's B what? That's B3. What about C? C, our main box is here. 1, 2, 3, 4 times our scale factor, which is minus half. We get what? Get 2. So 1, 2. So this point right here, that's C what? That's C3. So we can join. So and always remember, if scale factor is half or minus half, we're expecting to get something which is smaller from the what? From the pre-image. So right here, that's triangle A3, B3, C3, which was transformed onto A3, B3 by what? Enlargement, and we are given that the center was 0, 1, scale factor was minus half. So we just take every point to the center, then we multiply the number of boxes with what? With the center of what? With the scale factor, which is minus what? Minus half. So we end up with what? With this little triangle.